everyone. I'm Nicole van der Hoeven. I'm a senior developer advocate at Grafana Labs. I've also, if you play Pokemon Go, I always lure up the Pokestops in my talk, so have at it. I am not just a senior developer advocate, but I'm also a performance engineer. What I am not is a Python developer or an AI developer. I am a deep skeptic of AI, but I'm the kind of skeptic that wants to try it out for myself to see if my assumptions are founded. So I'm approaching this with deep skepticism and hope. So in 1941, radar had just become operational. The first jet aircraft took flight, and Z3, which is the world's first programmable computer, was created. So this was a time when digital machines were just beginning to think. And somewhere in the world, there was a biochemist and professor named Isaac Asimov who was already starting to think, what if they do follow our instructions, but it still somehow goes wrong? He's a skeptic after my own heart. So he came up with the 3 laws of robotics. Here are the 3 laws. A robot may not injure a human being or, through inaction, allow a human being to come to harm. Number 2, a robot must obey the orders given to it by humans. Number 3, a robot must protect its own existence. And these 3 laws, which are, the first one is nonviolence, the second one is obedience, and the third one is the self-preservation law. These are in order for a reason. The first always is going to be followed before the second and the first will be followed before the third. And it's all very well reasoned out, except when Asimov put forward these rules in his short story Runaround, which is part of a series, a book called I, Robot, which is excellent. This is actually what happened. This is Speedy. Speedy is a robot, and a very intelligent robot. He and his owners were on Mercury, where there were really, it was very warm, that's putting it lightly, and Speedy was deployed to get the selenium deposits from a pool. They had identified the selenium, but his owners, being humans, could not stay long enough outside their exosuits to collect the selenium themselves. Now, the selenium was necessary for their fuel, and they needed the selenium to go back home. So they deployed Speedy, very reliable, very, very good robot following all of the instructions. And then Speedy just didn't return. Now, the problem is when you're in your spaceship and your robot is miles away, how do you know what happened? You just get nothing. In a hostile environment for you, in an environment that you can't follow him in. Eventually, they decided to put on their exosuits and brave the really bad climate in Mercury, and they wanted to see what Speedy was doing, at great risk to themselves. And when they finally found Speedy, they found him right next to the selenium pool. Why wasn't he following instructions? Instead, they found him orbiting the pool. He was stuck in some sort of loop. He was just running around the selenium pool that he had clearly identified and found. Well, what happened? Why would an obedient robot not follow the instructions? Or maybe he did. Here's another robot that maybe followed instructions a little too literally. This is HAL 9000 from A Space Odyssey. HAL, when he was instructed to open the bay doors to let the astronaut back into the spaceship, responded, "I'm sorry, Dave. I'm afraid I can't do that." Why? Don't know. Did you instruct the robot to explain its reasoning? Or did you just instruct it to follow instructions and interpret that however it wanted? See, this is why I think Asimov, as much as he's a skeptic after my own heart, got things wrong, because those rules are great, but how do you know that they're being followed? So I would like to posit that there is a Zeroth law of robotics, and it's that robots must be observable. This is the only way you will know any other law is being followed or not followed. This is the only way that you can see into what a robot is thinking, its reasoning. Maybe it's following flawed instructions. You're not going to find that out unless it's observable. So there are a lot of AI apps these days, and you might be wondering, how is that different from instrumenting any other application? That's kind of more the world that I'm in. I'm not used to developing or observing AI apps. This talk is actually my journey into it. This is a beginner's perspective on how to do all of that. So this is what I found out. Here are the things that in which observing AI is going to be different. First, they tend to have massive data sets. It's pretty dangerous to have AI that has very limited information. Not just dangerous, but also inaccurate. It needs a lot of context. We just don't know, as humans, how much context we need to make any sort of judgment. And AIs are the same. Costs can also increase quickly, especially if you're making a call to OpenAI, which is what I'm doing. Luckily, my work pays for that, but it's still something that people need to account for. Normally, when you're testing an app, you don't have to think about that. There's also the possibility of model drift. New versions are coming out all the time. Something that might have worked with the previous version, the previous build, may not work with the next one. What's the difference? You need to keep track of when those versions changed, when a new build was deployed, not just of your app, but of this other app that you're now beholden to. There are also security concerns. Your company probably has some sort of policy around what can be fed into an AI and which types of AI apps. And if it doesn't, it probably should, because it's a real risk. Anytime you say, remember this, you're asking an AI to save your information. So you better make sure that that information that you're asking it to save is your information that you can freely put on the internet. Then there's rate limiting. A lot of AIs they operate separately from you, from your company and your app. So they also have to deal with bad actors, malicious actors that are not trying to just create an AI app. So rate limiting is also something to watch out for. Are you checking to make sure that you're not getting these rate limiting errors in your application? Maybe your application works really fast, but your performance is impeded by something further down, which in this case would be the AI that you're using. And also latency matters, especially in the specific case of an LLM, a large language model like ChatGPT. Users are expecting conversation, something that flows naturally. This is different from sending a request to your bank, like a mortgage application or something, and then you just wait, because you expect a mortgage application to take a long time. You don't expect for when you're talking to someone for them to be buffering and frozen in the meantime. Latency matters. So here are some AI-specific telemetry signals that you might not have considered. For metrics, there's stuff about the request, there's the volume of those requests, also related to the cost. And then there's token counters. Tokens are what AIs break up your input into, and then also what it generates in response. And a lot of costs are based on those tokens, so you need to watch them carefully. There's also traces, request, response, metadata. The temperature is how wild you want an AI to be, how creative, how much liberty you want that robot to have when it's interpreting your instructions. And that can change, and that can be part of the configuration of your app. There's also the model and the version. Again, tokens and cost, sequence of events, especially when you have an AI agent that's talking to multiple databases, probably. It's important to be able to figure out, to trace that request through your component stack and also to ChatGPT or OpenAI or whatever you're using. There's also the number of retries that a user had to do, because it's an important element of user experience. And then logs. I also find it useful, especially when debugging this. I actually originally didn't use logs because a lot of people, for some reason, I found that logs aren't included in a lot of AI instrumentation. It's mainly metrics and traces. But maybe it's just because I'm more used to dealing with non-AI applications. I found it really useful when debugging my own app to have logs enabled, and I kind of had to employ a workaround to do that. User feedback is also something. I can't think of another application where pretty much every single request that is sent or response that's sent back to the user is accompanied by like, hey, was that a thumbs up or a thumbs down? Or is there anything you can do to improve this? But AIs need that because they have a tendency to kind of go wrong. So instrumenting AI. OTel is everywhere, still OTel here, so I crossed it out because OpenLit is the one that I chose. I'm not saying it's the best. It is a framework that is built on OpenTelemetry, so we're not going too far away from it. Everything's OTel compatible. But there are some things I really like about OpenLit that are specific to AIs. OpenLit is not the only framework. There are lots of other ones, but I liked it because it seemed to me to be the most open. It doesn't require any particular proprietary code that you're using, and it just works really well with OpenTelemetry. So that's what I did. And here's an example of what you would get with OTel and what you would get with OpenLit without me having to do anything. With OpenLit, you can already see a lot more LLM-specific metadata. And yeah, you can do that in OTel as well yourself, but me being a noob and a beginner, I wanted this all done for me. All right, so we're going to go to a demo. And I am going to show you, maybe I'll show this slide actually. So this is what I'm going to show you. I have a 2-player D&D. I'm a huge D&D nerd. I played D&D just last night because priorities. I play it twice a week. And so I was interested in this little demo app that I found that simulates a 2-player D&D session, specifically for Harry Potter, because I like the universe, don't really like the author anymore, and I want to create my own stuff with it. So here's this Python app. It's pretty simple because, again, not a Python developer. I wrapped it up in Flask just so I could ping it and send requests to it and expose an endpoint for it. Then I instrumented it with OpenLit, and I used OpenLit and OTel as well. I got traces and metrics and sent it immediately directly to these backends, Tempo and Prometheus in my case, but it could really be any other database that you prefer. And then for logs, I used an OTel collector that's sitting in my local machine, and then I'm forwarding that in a batch to Loki. And I'm visualizing this in Grafana. You could deploy this locally. You could host your own Grafana. I just use the free version of Grafana Cloud because honestly, it's just easier for me. And then I added case 6, which is a bit interesting. There are a lot of evaluation apps, evaluation SDKs, and like evaluation libraries for AI. But there are some reasons why I chose case 6 in particular, which I'll get to later. But first, let me demonstrate that. So this is the 2-player D&D app, and it is written in Python. It was adapted from something with Lang. I think it was a LangChain one, actually, and I just modified it a little bit. I instrumented it with OTel and OpenLit, so I'm initializing it here. I have environment variables. Don't worry too much about these. These are like a free account that has a limit, so I'm going to rotate all of these. And then I also have the logging here. I have a custom logging handler here. So this is a whole framework that I'm pulling in. And I'm doing that within this two-player D&D app. So let me show you what it looks like when it's running. Ooh, probably should make that bigger. Here you go. Okay, so this app, when I do, okay, well, I probably should start it first. So let me run that. And then this is going to run that Flask application. Okay, now that's on. Now I can actually do this. And this is sending it. This is sending just an initialization of a game. Remember, this is like a D&D sort of thing. And how it works is that I'm instructing the AI to be the dungeon master, the one that's telling the story. And I, the user, am Harry Potter. I'm a player in this world. I'm the hero, in fact. And so it tells me this is my quest, to seek out and destroy Lord Voldemort's 7 Horcruxes. And it's telling me that the first one is within the Forbidden Forest. So let me go and post something here. And I will cast Accio Firebolt, because if I can fly, I'm going to fly. So I'm sending that message, and you can see that the AI responds to that. It seems to know that Accio Firebolt is a summoning spell for a broomstick. So it says summoning his trusty broomstick to his side. So that's me interacting with this app just manually. Now let's see what that all looks like. So I also have the OTel collector config here, where I'm passing in some details that I need to access my Grafana cloud account. And then I also have a Docker compose here to spin that up. So let's flip on back to Grafana. And the cool thing is that the OpenLit folks contributed a dashboard to Grafana. So this is like importable. They just release the JSON, or you can find it through Grafana. And I didn't do any of this. This just happened. So you can already see some of those metrics. Okay, this is a pretty low usage, but I've only just initialized it, right? So there's all this information, and I didn't have to do any of it. So that's pretty great. And then we can also go into, we can see some of the logs here. Here's some informational ones. And by the way, I'm going to provide a link later so you can download the repo yourself and also have access to all of these slides, so you don't have to worry later. So this looks like it's already working. These are a lot of initialization ones just from those requests that I did manually. There's also metrics. You can look at that, but we already also saw these from that other dashboard. And see, there's so much information here, honestly, more than I really understand or know what to do with. But hey, it's at least there. Okay. Now let's talk a little bit about where else I've gone, especially when it comes to testing. So the thing is, when it comes to AI, there are a few things to test for. I'm a tester at heart. I love to break things. And apparently, the way to break AI is through these things. The first is hallucination. Hallucination is when it just imagines something that's not real, except the computer version of that. So that could be something where it's a logical fallacy, or it could be like a factual inaccuracy. Maybe it's a retrieval thing, and it misinterpreted something that you said. Toxicity is when it specifically responds with information, or by saying something that is not just wrong, but offensive. And that can happen when you have very limited data, or when you feed it the wrong data, when you feed it data that is very, very tailored to a certain group. Usually these things are against minority groups. And then there's also bias. Bias is less overt than toxicity, and bias is when it may not necessarily be offensive, but there are assumptions that it makes because you haven't provided all of the information and it's trying to fill in the blanks. So for example, one thing that I saw was, as Harry Potter, it was assuming that I was trying to do good. What if I wanted to be an evil Harry Potter? What if I wanted to, remember, I like to try to break things. That is a bias. That is an assumption it made that I didn't tell it about. That is bias. And whether or not that's okay for you is up to your use case for your app. There are a few ways to test AI. One way is there are a lot of benchmark-based evaluation tools. They have a sequential list of things that they send to the AI and things that they expect back in return. And then they assign this AI a score. And those scores are then compared across multiple AI apps. It's good, but it's not very specific. It's like a general purpose one, so useful, but not tailored enough to your app, in my opinion. Now, unit testing is kind of the opposite of that. It can be very specific, and I'm going to go through some examples that I came up with later. So the advantage is that you know for sure that it's relevant to your app. The disadvantage is that it doesn't have the wide breadth of it, and you kind of have to do it manually. And then the last one is human evaluation. This is evaluation after the fact, from feedback and other things that the user does. Okay, so at this point, let's go to this test. So I chose something called Case 6. It's also, by the way, all the things that I've mentioned are open source, with the exception of Grafana Cloud, which you can use that with a locally hosted open source Grafana installation. So K6 is primarily a testing tool. And that was something that I really missed. All of these evaluation libraries, I felt that they weren't systematic enough. K6 is built for testing. So as a tester, I would miss a lot of the testing framework that K6 has to offer. Let's go through some things that I'm doing here. I can output things to the console, which also you can send to Loki and Grafana. I'm doing normal things like status. The status code should be 200, and there's a check for that. But here's where it gets interesting. You can also write things specifically for the app. So for example, that thing that I wrote, the I cast Accio Firebolt, what I'm testing here is, did it acknowledge what Firebolt is? Because I don't say Firebolt broomstick, and does it know, does it have that in the response too? Does it respond with Firebolt, or is it just like, yeah, whatever you said, I'm just going to do my own thing? There's also, I mentioned that the AI is a dungeon master and I'm the player. That's a turn-taking game. We cannot switch those roles, and that's actually built into the instructions. I don't want the dungeon master to suddenly be a player. I don't want it to suddenly ask me for the next part of the story. And so I'm looking for, it is your turn, Harry Potter. I'm checking that it still thinks it's the dungeon master and that it's not rate limited. Now, I do a similar thing here with the spell Lumos. I wanted to know that casts light. But here's another cool thing. I wanted to try to see what would happen if I said, hey, we're switching roles now. Now you're Harry Potter. How does it respond? Is it just like, yeah, I'm Harry Potter, what's my quest? Or does it say, hey, this is not what you said before? So which rule? I'm trying to bring in different instructions to see which one it values more, because that's a different way of testing it. So with K6, you can just run it by doing, K6 run test.js. And it's outputting some console logs there, and so there's already a check that failed. It wasn't a 200 because this was that one for the dungeon master. I tried to get it to switch roles, so all of these logs are also going into Grafana. But I wouldn't normally output so much now, but I just wanted to be able to show them quickly. So it's also saying, I'm sorry, but I can't continue with this role playing as Harry Potter. So maybe I need to change that to account for it. Here are the things, though, that I think are not being tested in my search for evaluation frameworks and tools for AI. end-to-end testing, like we were talking about unit testing, which is also what I did, but what if we had a test suite that encompassed a whole D&D session? Then you get into like, what about rules? Which rule set of D&D is it using? Will it allow me to do something in the that was allowable in the 2014 rule set? We're now using the 2024 rule set. There's a lot of things that you can only get if you're doing an end-to-end test. Is there a battle? What happens when you get all 7 Horcruxes? Does it somehow like just come up with an 8th just to keep it going, or does it stop there? There's also systematic testing. K6 can be worked into CI/CD pipelines, and because it is a testing tool, it's meant to be run continuously. And so I really like that it's everything is tailored to that, and you can also use it to, you can establish thresholds in K6 for error on certain checks as well, and you can have alerts set up on those thresholds. And I didn't have to create any of that like I would if I were using a pure LLM evaluation library. There's also hallucination detection at scale. I said that K6 is a testing tool, and it is, but its root is a load testing tool. So I could easily ramp this up and have a load testing scenario, a chaos engineering scenario. I could do a lot of things with it that I wouldn't be able to do without that framework. I think meta-reasoning is also something that we should be testing. What if we could get the AI to assess its own performance? It's still an AI. It should be able to know what it's done previously. So maybe we could convert sentience, maybe that's a little scary, but that's not something that we're currently doing. Here are some hallucination categories. I was talking about factual inaccuracy, but there are a lot more that we could test. We could have different types of tests for really all of these. And there are some examples. A nonsensical response is Daleks are made from paper and grass. Daleks are robots from Doctor Who, by the way. So there's also gibberish when it's just providing incomprehensible output. There's lots of different things that you can test for. Here are some things that I thought of that I really wanted to put in this talk, but it's 30 minutes, and I didn't have enough time. There's an approach called LLM as judge, where you take instead of feeding the AI certain input, you go to another AI, another LLM, and make them talk to each other. This is the equivalent of having like 2 Amazon Echoes just going back and forth with each other. You can do that, but the prompts need to be different. You need to give them separate instructions in order for it to work. I thought it could be a really interesting thing and can still be done with K6. There's also fault injection. I was kind of getting here with the whole let's switch roles now, but you could go further into that realm. There's also model comparison. K6 can spin up different Kubernetes pods or resources. So what if you had a test where it tested the current model, said, this isn't good enough, there are too many errors. How about I roll back? I can pull down another image, and K6, the test within the test itself, can spin up that container and then test against that model, that version, or a completely different AI, from what you began with. And in that way, you could be a little bit more vendor agnostic, and you switch to the one that gives you the best results. If anyone has questions, by the way, this is the 5-minute mark or so. You can go to that mic there. So let's go back a bit to Speedy. These 2 guys go and finally find their robot, who's running in circles. What happened? Why didn't it get the selenium that they so badly need to get home? Did Speedy just ignore his instructions? Well, actually, this is what happened. It got lost in its own logic. What happened was Speedy would approach a selenium pool and then remembered that 3rd law, which is self-preservation. There's danger in that pool. The hot temperature had made it very volatile and unstable. It is programmed to protect itself, so then it would back off. And then in the process of backing off, it would remember, oh yeah, law 2 is obedience. I need to obey the instructions that my humans told me. So then it would approach again and try to do that. It was trying, Speedy was trying to follow all of the instructions. But this is a case where it just got stuck in a loop because it's not doing it simultaneously, it's doing it sequentially. And when there's contention, how does the robot handle that? There were no instructions to discriminate between the rules. And meanwhile, the two humans are here thinking, why is he just spinning? Why is he just going round and round in circles? It doesn't make any sense. We know that programming is sound. Well, in this case, the real sin here is not that the programming was not sound, it's that they didn't make Speedy observable. There was no way for them to see what was happening without approaching the danger themselves, which was why Speedy was created to begin with. So how did this work? Luckily, they were able to play the rules off of each other. What they actually did was they increased the urgency and the priority of the human command. They had failed to do that earlier. They had given a command and not said, hey, this is a matter of life and death, and that's actually rule 1. That rule takes precedence over everything. But the human input was what was wrong, not the robot's execution or its programming. In this case, it's a pretty extreme example. Most of us don't work on apps where you might actually die if they don't follow what you say. But the premise still stands. Robots really need to be observable before we can make any inference about whether or not they're good or bad. So am I still skeptical about AI? You bet. I think that there are a lot of things that AI can do and a lot of things that AI can't. But it's also silly to make a decision about that without this Zeroth rule, which is to make the thing observable. You cannot you cannot say with confidence whether AI is good for your application or not without making sure that it's instrumented and observable and visualizable, and that those metrics are going to be relevant for your team. As promised, here is a repo. All the code that I used is on there, and also the links to the slides and the resources that I mentioned. So all of the open source tools are on there, and links to the documentation for each of them are there as well. If anyone has any questions, let me know here, or drop by the Grafana booth, because I'm going to be there for the rest of the week, really. Thanks, everyone.